So we need a unit and a numerical magnitude. Unit need not to be base unit or SI unit, and the number need not to be in standard or scientific notation. So as true value is 895, we have all of these value 3 millimeter or 4 millimeter less, so it cannot be accurate to within 1 millimeter, and they are all precise to within 1 millimeter. They are all close. The difference is just in 1 millimeter, so I choose B. We have uncertainty percentage in time 0.05 and in distance 0.6. We know from equation of motion that S equal half gt squared for the object that falls freely under gravity and from rest. So we can rearrange for g as follows, and we can use this formula to estimate percent uncertainty and distance, again 0.6 plus 2, because it is squared, means 2 t times t, 2 times 0.05, and we have the answer to be 0.1 plus 0.6, 0.7. So we have delta B by delta T is the gradient for all of these graphs. And as there is no air resistance, the object falls totally under the gravity, which is a constant force. So we expect the graph to be just a straight line with single value of slope, constant value. So answer is C. So for a projectile, we know that we have only acceleration in the vertical direction at any point along the path of the projectile. We have the horizontal component on velocity is the same, and vertical component just increases if there is no air resistance. So as we have a constant velocity and horizontal component because of no force, I'll choose either A or B. And as for vertical motion, we have constant acceleration. Again, air resistance negligible. So answer is A. Okay, we have from rest here, we have the takeoff speed, which is the final speed for the aircraft. We have acceleration, and we have some length required. Okay, we can't use S equal half at squared because we don't have any reference for the time. So we can use v squared equal u squared, which is 0 because it is from rest, plus 2as. So for the distance taken by the aircraft to reach a velocity of 4.2 from rest, we can have this formula, which is a rearrangement from this v squared over 2a. So 4.2 squared, oh sorry, 58 squared divided by 4, 2 times 2.4. This gives us S as around 400 meter, but this is 0.74 from another lens which the question asks about. So if we substitute 400 here and divide by this, we will find the answer 540. Certainly acceleration is gradient of Vt graph. Gradient of dt graph is V. Area under Vt graph is d. Area under dt graph has nothing. Okay, mass is the same both on Earth and on Moon, but weight certainly different. An O-level question. Upthrust U is rho g v. Okay, it's proportional to acceleration of free fall. Remember that this acceleration is g only near the Earth's surface, can be another thing on another planet. So as we have a frictionless surface, we have no external force. So we have momentum conserved and momentum before equals momentum after. Before it was 2 kilogram mass with speed 3, so it was 6. And certainly the second object is stationary, so 0 momentum. And after we have 3, which is mass of 2 plus mass of 1 times the v velocity that both of them are moving with. Okay, so we have v equals to 2 meters per second, and for kinetic energy before, it is half times 2 times v squared, which is 9 or 9 joule. This is before, and after it is half times mass of the stuck objects, which is 3 times v squared, which we have just calculated 4. So it is 6 joule, and the loss is 3 joule. We have here perfectly elastic, and we have no external force. Okay, so kinetic energy is conserved and momentum is conserved. So what is not correct certainly will not be C and will not be D. And it is also not B, because relative speed of approach is equal to relative speed of separation. So we cannot add both of them to give 0 because they are not necessarily 0, and as the speed here is scalar, so we don't have one minus the other to have a 0. Okay, so this is not correct. If we look also to a force acting on x plus force acting on y equals 0, all forces should sum to 0 to have no external force, so this is correct and cannot be chosen. Pressure will be due to air, which is BA, and will be due to water. And pressure of water is rho GH, and the H here is R and R. So it is C. Okay, we have here tension, and if we analyze it to vertical and horizontal components, we will find the orientation of the components like that. For the hinge, force cannot be vertical, okay? Because if vertical up or down, there will not be a horizontal component that balances the horizontal component of the tension. We need here a horizontal component in opposite direction, okay? And we need a vertical component, okay? Because we have choice C and D, oblique, okay? Whether it is oblique to the left or oblique to the right, it depends on the orientation of both components of the force at the hinge. And as they oriented like this, resultant or force F should be in this direction, and D is the answer. Couple is magnitude of one of the forces times the distance, perpendicular distance between the two forces, which is 2D. So as we have here 4 forces, 2 of them are weights and the other 2 are the contact force at X and Y. We want Fx, okay, so we don't want Fy to appear in the principle of moments equation. So we will take the moments around Y, and we have 2 forces in anticlockwise, which are the weights. So we have 700 times distance, perpendicular distance from Y, which is, this distance is 10 meter, and this distance is 10 minus 6, so it is 4 meter. 10 plus 4, it is 14, plus for the 200 Newton, we have 10 meter. This equals Fx, okay, because it is in the clockwise direction, times the distance 20. Okay, you can rearrange and calculate Fx. Okay, So we have here constant velocity for B, and any object that moves with a constant velocity means is that there is no force act on it. So there is equilibrium between tension and some other force. This force is the component of mg, weight of block B, in direction of slope. Okay, we have this angle theta, and if we make a perpendicular here, this angle also will be theta, so this is mg sine theta. Okay, this should equal the tension. Tension is caused by the Q block, and its weight is mg, so we can use mgv for power. Energy transferred per unit time is power, and we know that power is force times velocity. So mgv or mgv sine theta are correct. No resistive forces, acceleration is only g, and we can use equation of motion. Starts from rest, u equals 0. We don't have time, so v squared equal 2es is the right formula to use. 2 times g times s. We want s here. S will be at the top of the vertical loop. If we have this vertical distance 58 and this 32, so at the top the car from rest moved a distance of the difference, okay, which is 26, okay, 26 centimeter. So vertical distance for acceleration of free fall, which is vertical 2, we can simply substitute and find the answer to be 2.3 meter second minus 1. Okay, here is Q is wasted and input is E, and we need the useful work or useful output. We have that efficiency equal to useful output, which is E minus Q, because we gave E for the motor, it gave us both wasted energy and work. So if we need work, we should subtract E minus Q over E, and it is obvious that the answer would be C. Okay. As I said in a previous question, gravitational field constant or acceleration due to gravity need not to be 9.81. This is only for Earth and near the surface of Earth. So this formula applies for any other planet with any value of g differs from 9.8, and object must not be in a vertical direction. We have just seen that a block moving on a slope can have affect gravity or weight can have effect on this motion, although it is on a slope. Resultant force also need not to be equal to its weight. Okay, it depends whether there is air resistance or friction or not. So the only right answer is B, and uniform gravitational field means that G is constant. To find the stress acting on a steel rod, we are not care about the length. What we need is the cross section. Okay, and cross section here can be given by times diameter over 2, and don't forget to convert, okay, all this to power 2 because it is pi r squared, the area, and force is divided by this cross section area.